In this video, we're going to talk about arc length and with radian measure a little bit. Previous video, we talked about how we use radian measure. And here we're going to put it together. We're going to have a radius of our circle. It could be either there, or it could be there. And we have an angle here. And then we have S, which is called our arc length. That angle measure, theta, that's going to be equal to S divided by R. Or if you're going to solve it for S, you're going to have S is equal to R theta. And that's actually, the formula of the book is given to you this way. It's most going to be useful when we have it like this. But what basically says is that the arc is equal to the length of the radius times the degree measure. But the deal is that it must be radians. If you have a degree measure here for your angle, you have to convert first, and then you can use this formula for the math that you're going to do later on. So for example, let's say I had a circle and I had an angle and it was pi over 3 radians and my radius was 10, and I wanted to know the length of this arc that I had here. I would do S is equal to 10 times pi over 3, which would just be 10 thirds pi. Okay? And depending upon what you're trying to solve for, you can either figure out what the angle is or what the lengths are. So for example, let's say I had a radius of 10 and then I had an arc that had a length of 20. And I wanted to figure out what is the length of this angle that I have right here, the amount of that angle. I would say, well, theta is equal to 20 over 10, which is just going to be 2 radians. Now, a little word about what mathematicians do when they write radians. If you see pi in it, they generally assume that your angle is going to be in radians. If you don't have pi in there, if you just have a number, we also assume it's radians, but sometimes you'll see a little r here instead of the degree symbol, and they use that to represent radians as well.